So this is going to be the first video. Here's the manual. I have it here at the table with the robot. I have the section marked out for programming the robot. There's also sections up front for learning more about the installation and the setup and all that stuff. The table of contents is here at the beginning, so it's very simple, very self-explanatory. This gets into programming the actual robot. But the first video, I'm going to talk about just the general layout of the control and one feature, which is just a simple movement, two different types of movement. A MoveJ and a MoveL. MoveJ, move joints, MoveL, linear move in Cartesian space, which I'll go into further detail about later. But first of all, so this is what happens when you first power up the machine, or power up the robot, just by pressing this button. It takes about 2 or 3 minutes for it to load all the way up, so power it up, walk away, come back. The robot, when it starts out, will be in whatever position you left it in. Doesn't really matter. So first off, if you have this pop up, you'll want to make sure you release the emergency stop button, just like all other emergency stops, by rotating, and say go to initialization screen. And it'll pop up with this screen, and this will pop up pretty much every time. This little indicator down on the bottom means that the robot arm itself is powered off. So even if this window is closed and you come to this screen, which is another option when it turns on, it'll give you this screen, and then this signal down on the bottom will say, hey, it's just letting you know that it's turned off. So you'll press this button and press on, and then it'll power on, gives you the whole boot sequence. So it'll be booting up. You'll want to check your payload. This gripper is roughly, 2 or 3 pounds. So, 1 kilogram is 2.2 pounds, so 0.75, get it close enough. It's just so the robot knows what kind of weight it's dealing with. So start. After that, and you'll hear it and feel it. It'll release all the brakes inside of the joints of the motors and make some clicking noises. That's perfectly normal. And then after you've got all green all the way across the top, you can just hit exit down here at the bottom. Now it says, hey, what do you want to do first? Do you want to run a program? Do you want to program the robot? Or do you want to configure the robot installation? So let's say, for example, we're going to program the robot. Meaning we're going to start fresh, brand new program. And just talking about the layout of the screen, starting at the top left, it's kind of like different tabs. So on the Run tab, it changes everything on this screen. The Program tab changes it to this screen. The Installation tab changes it to this screen. The Program, obviously, is where you build your program sequence, and with all of the different types of functions here on the left. The Installation tab, which is next, which is basically the layout of your setup, so to speak. So there's your TCP, which is your tool center point. So basically the layout, the position of where the part would sit in your gripper. So you can see from the robot flange, it's offset a little bit because of the length of the gripper. For that, you shouldn't really have to mess with. For the dual grippers, it's a little bit different. There's 2 different TCPs. There's gripper 1, gripper 2. Tool center point, again, is what that stands for. And then it's offset and rotated because of all of the bracketry that's required for that. Mounting is another option. You can set up the robot base on like a 45-degree angle. You can set it up so that it's inverted with the robot hanging down, working down onto the table space. But that's where you establish this. Again, see here on the side, there's different options. You can offset your angles, all of that stuff. But again, that's not really anything that gets messed with frequently. I/O setup, that's basically your inputs and outputs inside of the control box. We'll go into that later, but inside the control box there's digital inputs and digital outputs to control things like solenoids, to open doors, to have sensors for status of certain items and things of that nature. So that's what that is for. And variables are installation variables that you can establish. That's a more advanced deal. Startup, you can set it up so that when you power on the robot, it'll automatically load one particular program and automatically initialize and all of these things. It's a little bit fancy, not really necessary. It's better to just understand how the robot functions. Obviously, that's a 2-second improvement, but then if you have to change your program, blah, blah, blah. It's up for debate. Do what you will. Smooth transition is basically your control of how long it takes for the robot to stop if you hit emergency stop or press the stop button for the program operation. Hard stop or soft stop just basically controls the deacceleration speed of the robot. Again, not something that you really mess with. Conveyor tracking, so if you're being fed by a conveyor belt, you can establish the communication and speed of the conveyor. Screw driving, if you get a screwdriver to mount onto the end of the robot, this is where you set that up and control its function. They're actually pretty cool. Google some videos for automated screwdrivers. It's pretty slick. Home, you can set up an auxiliary home position. The default is straight up in the air. Tool I/O, it's basically set up right now so that it just operates off of the Robotique grippers. This is a separate component from the robot arm itself. So the gripper is a separate item, and it has its own software and all that, and that's how it's controlling the team. Safety, you can set robot limits, so you can say, okay, here in this area is going to be my machine, don't smash into my machine, blah, 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 things like that. There's a whole section in the manual for that. It's very good. Joint limits. The robot automatically has hardware limits, but you can establish soft limits so that it doesn't over-rotate or anything like that. I haven't seen any purpose in doing so, but you know, you can establish. You have absolute control if you want it. Tool direction. You can control the directions of your tools. I/O. Again, you can change the names of these so that they're a little bit more legible and easier to read. Hardware. I believe you can remove the teach pendant, and the other information here I have never seen before, like the injection molding machine interface. So, learning opportunity. Safe home. I'm not sure what this is. I'm gonna have to read in the manual what that is. That's new. 3 position. You can do this for calibration. 3 positions. Yes. Again, another item I need to read more. Features, another item that's very useful is basically your work offsets, or the reference frame that the robot has for your work area. For instance, inside the machine you have your table that's laid out in Cartesian space inside of the mill. So you have your X, Y, and Z relative to that table. And say, for example, if you took that table and put it at a 45-degree angle, kind of like in a lathe, then that is your Cartesian space. That's your frame work offset or frame of reference. You can basically establish the same things here by using either a point, a line, or a plane. Line, obviously, is for example, like the center line of the spindle on a lathe. So that's pretty much your primary control of your Cartesian space is along that center line. A plane is basically, you know, like a tabletop, like in a mill. That is your plane reference, where you have your 0 in the top right-hand corner, and then, you know, everything else is negative in this direction and Z positive up through the air. And that's how you can establish your frame of reference for the items you're working with. So say, for example, the table of in feet of parts was on an angle, you can lay that out as a plane, and then the robot will know to move relative to that plane instead of just in a normal up and down, left and right, relative to the ground. Going through this pretty quickly because it's not things that you use often, and usually you have to do it in order to fully understand it. UR caps, that's where you go. Field bus is for external communication, for external devices that you would use via Ethernet and internet cable, Modbus, all of those things. Very complicated. UR caps is basically external peripherals that have their own software built in. For example, the gripper. That's what we have that shows up as the gripper here. This particular UR cap also has the capability for a vacuum gripper, which we haven't purchased, but it has the software already built in. So you can scan for other grippers there, and if you need to activate the gripper, you can just press the activate button here. Also, it will pop up in this little quick key up here in the top right that says UR+. That's where you can access the gripper functions there for open, close. You can control your speeds and force. Really simple, very intuitive. Just try it out, press buttons, and you'll know exactly how it works. Down here at the bottom is your speed slider. So basically the control of the speed of the robot. So, you know, if it's at 25% speed or 41% speed, for example, the robot's going to move at the 41% of the programmed speed. That doesn't mean that it's going to move at one constant speed, but if you have some points that are faster than others, then it's just going to go a percentage of that program speed. You can also run programs in simulation. You can turn on the simulation mode here and go to the Move tab and watch the robot move through the simulation, which is pretty useful for when you're proving out programs. You just want to watch it move through Cartesian space. You can also watch it in the graphics window, so it'll show your waypoints and the robot will move to get to each of those waypoints. It's very useful for first time through a program. Moving on through the top here, we stopped on installation for a very long time. Move, this is basically your hand jog in reference to the machinery. You go to the Move tab to move your robot relative to Cartesian space. So you can move it relative to different features. Like I said, you can set up your own planes or your own work offsets, and you can move relative to those. The basic ones are relative to your base. So the home work offset for the base motor here, it goes off in some odd direction, so it's not very easy unless you're moving in the Z direction. Otherwise, it's a little bit difficult to get it to line up properly. That's why it's important to set up your work offsets before you get too far into programming anything. Tool is another useful one, is your work offset relative to the tool. See how blue is Z, green is Y, and X is X. You know, it's color coded here to match color code here, and then your rotational positions here. So this will move, for instance, this will move Z in this direction, X, and Y, which it's relative to the gripper. So if you rotate the gripper like this, you're rotating in that direction, and then you move relative to X again, it moves relative to the gripper's position, not relative to Cartesian space. So then Y, for example, would be along this axis instead of being flat. That's just one quick example of that. So just being able to jog the robot into a position that you like. You want to make sure you're relative to the correct feature, and then just turn your speed way down low to like 5%, and then just like gently tap the button and watch what direction the robot goes. That's the easiest way to figure out, until you memorize it, obviously, of, you know, looking at the picture and understanding your space, where the robot's going to go when you press certain buttons. But the safest way to move the robot, just talking about moving the robot in general right now, is using the free drive button. You basically hold this button down. You have to hold it while you're doing it. You hold that button down and the robot essentially goes limp. You can hold that button and you can move the robot by hand, position it, and things like that. That's especially useful when you're programming MoveJs, which we'll get into here in just a moment. Hold on to your hats. When you're doing MoveLs, I find it's easier to use the Move tab, because you're simulating what the movement that the robot's actually going to take. So it will move relative to Cartesian space for MoveLs. MoveJs are usually gross moves to get into an approximate position. And I/O, just going across the top, is your inputs and outputs page, where you have all of your different options. You can label them so that they're more self-explanatory. Like if you look at the I/Os on lathe 1 and 2, and I believe 6 is set up this way as well, all of them are labeled appropriately for their actual function. That way you know what you're doing when you go and press buttons, or as you're programming it, those I/Os to do certain items. Very easy. Log is just basically the status of the robot. You can check temperatures, current draw, voltage draw for each joint, status of each joint, you know, controller information, and any past alarms that may have had of any type. Informational is just plain old information log. So I don't believe there's been any collisions or anything with this robot yet, which collisions are pretty minor. Yellow is something that is, you know, it had an issue, but it's not a big problem. Red means like it's an alarm, like there was some kind of mechanical or software or electrical problem that caused the robot to alarm out or have an issue. And yes, there is a clear button there, but the log file cannot actually be deleted. It can always be extracted back to the original purchase date. So if you screw up, don't worry, it can be found. Don't need to go over those items too much. Basically, this is your program information right here. program name and installation name. So program unnamed because we haven't saved it off as anything. We haven't started programming yet. Open, you know, if you want to open up an existing program, you can go in and grab an existing program. Like I made a test program. You can save off your programs on here, but you know, if it's just for messing around, just make sure you delete it when you're done learning how to do it. Just be sure to put your name on it. That way anyone knows anyone who comes up to it knows who to go to if they have questions about that particular program. Gripper tutorial, it has all the different functions of the gripper inside of that program, and it walks you through and teaches you how to use the different functions of the gripper. And then put into box, it basically just folds the robot up into position for it to go into its box nice and tidy. Yeah, that's the basic rundown of those. And then save. You can save your program, you can save your installation, or you can just save all. I recommend if you're going to save, just save all. If you've made any changes to anything. Okay, getting on to programming MoveLs and MoveJs. Talking about Move, when you tap the Move button here, you notice it pops into your tree wherever your cursor is. So if I put my cursor down here and tap Move, it'll nest it down inside of this MoveJ, which is fine, but it just makes it really easy to like group certain items that for a certain function. Like, okay, for this section, we're going to be loading the collet or what have you, which we'll get into labeling later, but that's just really quickly how you can do that. And you can, in the command tab here, you can define your work coordinate system that you're going to move relative to. So you can move relative to your base, your tool, or whatever positions you have are previously established. And if you have multiple grippers, you can establish what gripper it's going to move relative to as well there. Or you can have it ignore that completely, and you can just use the robot joint angles, which means it's just going to go to that position for this motor, you know, all 6 motors all the way through. That's useful for certain situations that I can't think of off the top of my head. I don't use that very often. The different moves, MoveJ, MoveL, and MoveP. There's 3 of them. We're going to talk about just MoveJ and MoveL for right now. MoveP is a little bit different. It's basically like a cutting path where your feet and speed are controlled and the robot maintains consistent speed throughout the entire trajectory of that particular move. But anyways, MoveJs, moving the joints into a position. So MoveJs are really good for doing coarse movements. We're going to delete that other move out there. And we're going to set our first waypoint. We'll pretend like this is where we want it to start. And we'll set that as set, and you select the waypoint, right? You select the item you want to edit, then you select set waypoint. And then you say, okay, this is where I want to start. Okay. So that's where the program's going to start every time because it is the first waypoint. So now we want to move the next position. So we press the waypoint button here and it drops it down in the tree for us. We'll say, okay, set waypoint. So you press the set waypoint button. And then I'm going to put this down because I have a hard time holding my phone and doing this at the same time. Maybe I'll be able to finagle it. Let's give it a try. So holding down the button, then I just take my hand and move the robot over here. Cool, that's exactly where I want to go. Release the free drive button and press, so that you can see the screen again, and press OK. Now those 2 waypoints were MoveJs. Now I want to do a MoveL. So because it's part of the same feature or whatever, however I want to organize it, I'm just going to add another move node right here just by pressing the move button, and I can see it has MoveJ selected, and the command window has the move information here and all of the information that I need to change it. So I'm going to change that to a MoveL. Your tool speed and everything moves and changes and yada yada yada. That's fine. So we're going to set waypoint, and we're just going to move this. Oh, got to turn up my speed a little bit. I'm going to set this waypoint up a little bit. And then I'm going to add in another waypoint and set that one to go back down. If I can press the right button. And we'll just have it go down to there. Cool. Now, in your program, if you select your robot program button here, or node on the very top, you can control your program to do a few different things. You can add before start sequence, so it'll perform a certain function before it begins the actual body of the program. You do load variables, whatever, you can do anything. There's a certain purpose for that. And then set initial variable values, again, for setting variables and and items like that. And then you can also loop the program forever, or you can only have it run the sequence of the program one time. This one, we're going to loop the program forever. And we've already programmed it. We've laid out our waypoints. There's nothing in yellow, which means that we're good to run. We can press the play button and it won't alarm out on us. We'll go to the simulation tab, and then the button, and then we'll go graphics, and see how it drew the lines of the positions for us here. And you can rotate it just by tapping on it and dragging, so we can see where the robot's going to go. And then we can press play. Press play robot, and then it'll start at the beginning, draw the line, move up, move down, and back to the start. Then it'll do the same thing, starting again, because it's set to loop forever. Boom, boom, and back to start. See, very simple program. Now we'll turn the simulation off, going back to black, or the real mode where it's going to run. We'll press play, and it'll say play robot. Play robot from the beginning of the program. Then you tap that, and it comes to this screen here. The ghosted image here is where the robot is going to move to. And it basically simulates where the robot's going to move, so you can watch it. I like to, especially over on the machines, I like to use the free drive button to move the robot into position so that it's a little bit closer, because if it's inside the machine or anything like that, you're probably going to smack something. So just getting the robot close to where it says it's going to go is usually a good indication, or a good way to start. So holding that button and then moving the robot by hand into position. But because it's only going to be moving about 1 foot, I'm going to turn my speed down to about 25% or so. And then you just hold down this button, and then the robot will slowly walk its way down into position. Nice and easy. Okay. Now once it reaches its starting position and stops, the button changes from move to position to play the program, which is really handy. I'm glad they made that change. So you press play. Now the robot is leaving it on 25% speed, the robot's gonna do those movements that we just programmed. Very simply, very grossly, nothing complicated. Now it's moving back to the start and starting again. So very basic, very simple. I expect everyone to be able to come up and do something like this fairly quickly with confidence. Don't be afraid. If you crash the robot, it's not going to hurt you. It's not going to hurt the robot. For example, I'm going to turn the speed all the way up. So it's moving at 100% speed. And I mean, it cooks. It's not moving slow. But it's not going to hurt you. If you put your hand out, I'm going to collide with it. And it really doesn't hit hard at all. Like, barely hit me. Like, if it hit me in the head, I wouldn't even have a headache. And it just says, hey, protective stop. We ran into something, basically. Again, yellow, not the end of the world. It's no hardware problems, nothing like that. It's just, hey, you bumped something, and it's outside of the safety limits of the programmed robot. You say, okay, it bumped into something. I'm going to move the thing that it bumped into, my hand, and we're going to start again. So you can say enable robot, resume, and then it'll pick up right back where it left off and fly through the air. Very simple. Anyway, yeah, that's about it. Simple, straightforward, and that's how you move the robot around. This is lesson 1. We're gonna roll through these quite quickly. The other videos will be much shorter because this was a big introduction to the control and how to navigate it, but the best way to do that is to simply get on it and press buttons. There's nothing you can break. There's nothing that can't be fixed. So please go and see and do.